to take an equation. If I write out an equation, the values that satisfy that equation, that means the coordinates that I put into that equation that make that true, are all on a line. They're all on the same line. That is a linear equation. That is a line. So if I, here, let's get rid of this now, this and this. And let's go to here. There's 10, 10. That done. Minus 3x plus 4y equals 12. Okay. So if I take a coordinate and I substitute the coordinate that's on that line into the equation, the first coordinate I have here is minus 4 and 0. So let's put that into the equation for x and y. So minus 3 times minus 4 plus 4 times 0 equals 12. What's minus 3 times minus 4? Positive 12. So you notice then that the left side and the right side equal each other. So if I take any coordinate on that line and plug it in for x and y, the left side and the right side are going to equal each other. So the solution set for this particular equation is any x, y that's on that line. That's the solution set. Now, an inequality has a solution set that may be on that line, may not be on that line, but it's in a region. So we need to demonstrate how do we show that in a region. Well, we start from scratch here, and I'm going to show you how to do it first on paper. And then I'm going to show you how to do it on Desmos, which is what you're going to primarily use anyways. Okay? So, for example, minus 3x plus 4y is less than or equal to 12. All right. So the first thing, and again, write these down because these are steps that you're going to use. Put these down in your book. Okay, so the first thing that you do actually to graph this is graph it as an equality. You graph the actual line itself. So I change that less than or equal to an equal sign. All right. Now, you were taught last year how to graph a line in 3 different methods. In each of the 3 methods, you need a minimum of 1 coordinate and either a second coordinate or the slope of the line in order to graph it. So we can do 3 different ways. The first way I can do it is find the intercepts. Put 0 in for x, solve for y. Put 0 in for y and solve for x. That would give me 2 coordinates that I can graph and then draw the line through it. All right? So I'll put 0 in for x. That means 4y equals 12. Therefore, y is equal to 3. Y divided by 4, or 4y divided by 4, 12 divided by 4. Now I put a 0 in for y. Minus 3x equals 12. 12 divided by negative 3 is negative 4. So I now have 2 coordinates in which I can graph this. Again, I'm going to show you the paper style, and then we'll show you on Desmos. Okay, 1, 2, 3, 4. Now, the first order of business, you have to determine, is the line solid or dashed? Is the line solid or dashed? Now, what determines that is on the inequality, is there an equals to part of it? Is that less than or equals to, or is it just less than?
Less than or equals to.
Less than or equals to. This line under here indicates that it's less than or equal to it. Therefore, it's a solid line, which means that all the coordinates on that line are going to satisfy that equation. So I draw a solid line like this. Okay. So that's method number 1. Method number 2 to graph this would be to take that equation and put it into y equals mx plus b form. So let's solve for y here. I'm going to first add x to the other side. I want everybody to write this down. Add x to the other side, 3x to the other side. Then I'm going to divide by 4. Okay. Now, looking at this equation right here, that is in y equals mx plus b form. So again, stuff that you took last year and the year before. What is the y-intercept in this equation?
4.
No.
+3.
Okay. If I ask you for the y-intercept, you give me a value. If I ask you where your starting point is, your coordinate, what do you say? No. Is that?
3 -4.
No. Close enough. Okay. What is the y-intercept in this equation? It's your b value. What does the y-intercept tell you? Where does the graph cross the y-axis? What's the coordinate where that graph crosses the y-axis?
0 and 3.
0 and 3. There's the first thing that I do. All right. The m represents my slope. That's my map. Where does my map tell me to go? Alex, wake up.
Up 3 over 4.
Very good. Up 3 over 4. Right there. So that would be the secondary coordinate on this graph. And then you would draw a line through it. Again, it's a solid line because it's less than or equal to it. So that was method number 2. Those are the 2 primary methods we used last year to actually draw a line. Now, I'm more inclined to have you just simply put the equation into the Desmos. And then basically put 2 coordinates off of that line onto the paper, and then you have to draw exactly what you see. Now, here's the last part of this. This is brand new to you. You have not seen this before, so I want you to pay very close attention. It says less than or equal to, which means we have to shade either above or below the line. The shaded region is all of the coordinates that satisfy that inequality. That means if I put them in for x and y, whatever's on the left side is always going to be less than or equal to 12. So all you have to do is draw the line and then shade it. So how do I determine where to shade it? Well, I pick a coordinate, any coordinate on one side of the line. I personally use 0 and 0 all the time because the math then becomes easy. So I'm going to take this coordinate right here and I'm going to substitute it into the inequality. And if it's true, then I shade that side of it. If it's false, then I have to shade the other side of the line. So let's put 0 and 0 in here. What's 0 times negative 3?
0,
0. What's 0 times 4?
0, 4. No, 4, 0, 0.
What's 0 plus 0?
0.
0. Is 0 less than or equal to 12?
That's less than.
It's less than it. That means I shade this region like that.
Where do you get 0 from?
I picked a coordinate. I chose a coordinate on one side of the line and I plugged it in. If this did not satisfy that inequality, if it was false, then I would shade the other side of it. So let's go back to Desmos then, and let's go to here, back this up, less than or equal to, et voila. There's the region. Now, if you pick any single coordinate in that shaded region and you substitute it into the inequality, it will always be true. Whatever the left side equals will always be less than or equal to 12. That's what a linear inequality is. Okay? All right. Where you're going to have the most amount of difficulty is when you have to read the problem and write your own equation out. But we're going to go through this a little bit more now. First thing I want you to do is I want you to look in the keep in mind part of this. We're going to read this together and I'm going to make some highlights that you need to understand. The boundary of an inequality in two variables is a straight line that creates two half planes. Essentially what that tells you is the boundary is the line itself. That's what that is. That line divides this graph into two parts. That's called, this guy right here, I'll write it up here, is called the boundary line. So any line is considered the boundary. One of these half planes includes the solution set of the inequality. The boundary may or may not be part of the solution set. Okay, so again, any coordinate, we can pick anything. Let's pick this coordinate right here. We'll say that that coordinate is 10 and 0. If I substitute 10 in for x and 0 in for y, that inequality should be true. What is 10 times negative 3? Negative 30. 4 times 0? 0. 0 plus negative 30? Negative 30. Is negative 30 less than 12? Yes. So you could pick any coordinate in this area here, and it will satisfy it. It's called the solution set. You're no longer looking at just the line, trying to find a point on the line. You're trying to find an area on the graph. A continuous solution set contains all of the points on the solution region. A discrete solution set contains some but not all of the points in the solution region. The points with whole numbers or integers coordinates. Okay. Now, we're going to get into a whole pile of stuff as we go here. But this is what we call a continuous solution set. It means that if I took decimals and plugged them in there, it would work. But you're going to do questions in which integers and whole numbers are a part of it only. If that's the case, then instead of shading the region, I dot the region like this. So we'll talk about that when we get into other questions. When no domain or range or context is given, assume the domain and range of the set of all real is the set of all real numbers. So we do have to get back into that a little bit as well, understanding what domain and range is and going through it. In real world situations, solution sets may be restricted to specific quadrants. We'll talk about that. To complete the graph, solution set, test a point. All right, we just did that. Okay, let's look at this second question on page 149. Actually, no, let's skip that. Let's go to question 1 on page 50. All right, I'm going to go through these and graph them with you. Okay, so the first one is this. Y minus x is greater than or equal to 10. All right. You have a choice as to how you want to graph it. I'm going to use y equals mx plus b. We are not today going to automatically go to Desmos. We're going to learn how to graph again. All right. And then you can use Desmos to check the solution. So the first thing I do is what? What did I do the last time? What do I have to do first in order to graph this? Make it an equation. So I'm going to change this to an equation. Again, this is in your book. I suggest you write it down because it is your answer that I am giving you right now. Y minus x equals 10. All right. How do we want to graph this? I'm going to change this into y equals mx plus b. Get it? Y by itself. How do I get y by itself?
You add x.
Okay, I need to get rid of this guy from this side, right? Plus it over to the other side. Y equals x add 10. Okay. What is the y-intercept? 10. What's my starting point?
10.
Nope. When I ask for a point, I want a coordinate. So 0 and 10 is my starting coordinate. Okay. Have you guys graphed before? Yeah, all of you? Okay. So 0 and 10 is my starting coordinate. So we go to here, go to here, and I go all the way up to here. 0 and 10. Okay. That's my B, that's my starting coordinate. What is my slope of this line?
M, right?
Nope. Well, yeah, it is, yes. Correct.
So 1.
Yep. Very good. 1 over 1. That's the value, that's the coefficient that is in front of the x. So 1 over 1. So where does my map tell me to go from 0 and 10 then? Up 1, right 1. Okay, so there's the first thing. Now I have to decipher. Is it a solid line or is it a dashed line?
Solid.
How come?
Left or it's equal or greater.
Absolutely. Equal to. That makes that a solid line. All right. Now to get the solution set for the inequality, I have to find a shaded area. What do I do to find a shaded area?
Pick a coordinate from the bottom.
Pick a coordinate. It can be from anywhere. But again, math is easy when I use zeros. So I'm going to use 0 and 0 again. There's 0 and 0. So I go 0 subtract 0. 0. Is 0 greater than 10?
No.
No. Is it equal to 10? No. So this is not in the solution set. So I shade up here.
Why up there?
Because if this is not a part of the solution, then none of these coordinates are. Only up there. So if we took a coordinate, let's take a coordinate over here. Gavin, let's take a coordinate up here. That's 12 and 12. Okay? We'll say that that's 12 and 12. Make sense? I'm just picking a coordinate. Got me? All right. So, did I do that? No, I can't be a part of it. My bad. I'm going to have to go with, that's 0 and 10. Up 1. Up 2. Takes that to 0 and 12. Let's use that one. 0 and 12. Okay? So that's this coordinate right here. 0 and 12. I put 0 in for x and I put 12 in for y. What's 12 subtract 0?
0 or
12 subtract 0?
12.
It's 12. Is 12 greater than or equal to 10? Yeah. So therefore I shade over it because it satisfies, it makes the inequality true. 0 and 0 made the inequality false because it did not check out to be greater than 10. So if it isn't in the solution, then the other side is what you shade. Okay? All right. So now we quick check this. What was the equation? Y minus x
Equals greater than.
greater than or equal to 10. There you go. There's your graph. Okay? That's your quick check. All right. Let's try the second one now. Second one is y is less than x add 3. All right. What's the first step now to graph the line? Maddox. What's your step say? You should have wrote down your steps. What do you do first? Okay, so write this down. the first step, put it over here, put it somewhere. The first step is change the equation to equals. That's your first step. Write that down. Change the equation to equals. Y equals X add 3. All right. Is that in Y equals MX plus B form?
Yeah.
Yeah, because the Y is by itself. Therefore, it's MX plus B. What's the B value in that equation? 3. The B value is 3. Do you know why that is? Honest. No? Okay. So this is last year. B is whatever number that is over there, Maddox. That's 3. Got me? Okay. M is the number that's in front of the X. What number is in front of the X right now? Okay. It would have to actually be a 0. So if it's not there, it's 1. It's 1. Okay. So that makes the slope 1 over 1. Okay. What is my starting coordinate then? Where do I go to start graphing this?
Up 1 over.
Nope. My starting coordinate is the y-intercept. 0 and 3. So I go 1, 2, 3, right there. You understand that, Maddox? You understand what I did there? I'm starting right here at 0 and 3. Because the y-intercept is 3. The y-intercept is where the line is going to cross this axis. Remember that? It's going to cross it at 3. Therefore, the x value on this axis is 0. So it go to 0 and 3. That's my starting coordinate. Now my map tells me where to go from there, Maddox. Where does it tell me to go? Up 1, over 1. So I go up 1, over 1 to right here. Okay. Now, Maddox, you follow me so far? Better? Better? Yep. Okay. Do I have a solid line or a dashed line?
Dash.
Why?
Because it doesn't have a line underneath it.
Very good. All right. When you look at this right here, there's no equals to part of this, which means that none of the coordinates on the line itself are a part of the solution. So I draw this like this. A dashed line. Okay? So draw your line, draw your picture. If you look at the top of the next page, look at the top of the next page. There's a graph for you to draw that for 1B. They want you to draw it at the top of the next page. Or you can just put it on the bottom underneath. Works.
I was just writing down what you were doing.
Yeah, boy.
I did the same thing.
Could have told you before.
I never noticed that.
Probably should have, eh?
Did anyone notice that?
No.
Okay.
Scabs, whatever.
I need to shade. I have 2 parts to this bad boy. I got down here and I got up here. How do I know where to shade it? What do I have to do?
Put 0 and 0 in.
Okay, I'm going to put 0 and 0. That's this coordinate right here. That's 0 and 0. I'm going to put it into this equation here now. That gives me, on this side, it's 0, less than 0, add 3. On the right side, what is 0 plus 3? 3. Is 0 less than 3?
Yeah.
Yes.
So then do I shade that side of the graph or do I shade the other side?
That's what I'm confused on. Like, what's
Okay.
the shape?
The side that I shade means that when I put X and Y into there, it's always going to be a true statement. it means that whatever's on this side is going to be less than what's on that side. So I tried 0 and 0. Is 0 less than 3, Gavin? That means that all of the coordinates on this side are going to be less than the right side. So I go like this. I shade this side because it worked. If it didn't work, if this was not true, then I'd know the other side is to shade. Follow? Okay. So I could take this coordinate right here, 0 and -4. Put it in there. -4 is less than 0 plus 3. Is -4 less than 3? Yeah. If I take this coordinate right here, -3, -3, and put it in there, -3 less than -3 plus 3. -3 plus 3 is 0, yeah? Is -3 less than 0? Yeah. So I can pick any coordinate anywhere in there, and when I put it into the inequality, it's going to be true.
But on the other side.
But on the other side, so this coordinate right here is 0 and 4. All right? If we put that in for it, 4 less than 0, add 3. Is 4 less than 3? No. So none of those are going to work on that side. So I don't shade that area. Make sense now? Okay. How are we doing? Do one more?
Sure.
Sure?
Yeah.
Okay. Let's do one more. Well, here's an interesting one. It's a simple one, but it will confuse everybody. Maddox, what's the first step I do now? Change to an equal sign. Y equals -3. That's the equation of this line, Nathan.
I'm listening.
Attaboy. Y equals -3. What does that line look like?
I didn't think it's a line because it's 0, so it's more like a bullet.
Okay. It's a good take on it. Does anybody else have a take on it? What does that look like? Is it just a point?
Is the line just right on the line? Because X is 0.
You're close. You're close. All right. All right. If I had it in this form, which it is, what is the y value? What is the y-intercept?
-3.
-3. Okay. What is the slope of that line?
1. 0.
What do you got?
0.
How come? Because there's nothing there. What is 0 times x? 0. So if the slope, and you thought this last question, the slope was 0 because there was no number in front of it, it doesn't exist. There's no x there. So what is the y-intercept? -3. So let's go to -3. 1, 2, -3. That's right here. Does it matter? Does it matter what x is? Will that change y in any way? No. What? Excuse me. What type of line am I looking at here? Well, you're okay. You're thinking the right way. Perpendicular to what?
To X.
Okay.
The y-intercept.
Yeah, you're right. You're absolutely right. First of all, is it a solid or dashed line?
Dashed.
Dashed. How come?
There's no line.
No equals to. Check this out. Here's your line. It is perpendicular to the y-axis. It is a horizontal line. Now, if that equation read x is greater than -3, what would that line look like?
It'd be up.
What would it look like? Hunter, what would it look like? Vertical line. Oh boy, I knew you knew it. It would be a vertical line. If this equation read this, it would be a vertical line up and down. There would be no y-intercept for that line. So that's the first thing. Okay. Now, just with your intellect right now, without having to do any math really, the equation says y is greater than -3, yes? So am I going to shade above that line or below that line?
Below. On.
Interesting. Above,
I
Below.
said below.
on. You said below it?
Yeah.
You said below, you said above, you said on. All right, show of hands. What'd you say? Below. How many of you agree with Nathan? Y is greater than -3 is below the line. You agree with yourself?
No.
Okay, good call. All right. How about this guy? Kane says above the line. How many of you agree with Kane? All right. How many of you having a hot clue? Nice call. All right. So we're still got some work to do. All right. I need you to think this through for a second. I don't need to put a point in there. Where are the y values greater than -3? Above -3 or below -3? Above. Is 5 greater than -3? How about 4? How about 1 million? Good call. Is -4 greater than -3?
No.
No. I simply just needed to know that I needed to shade up there. Now, you could have put in a point. You could have put in 0 for y. Is 0 greater than -3? Yes. Yes, it is. So, in that particular question, when you're shading, and you're going to see this often, a vertical or a horizontal line. You're going to see this often. You shade either above the line or below the line. Okay? All right. I can't let you go just yet because we got some girls away for 2 days and you guys, boys, are away tomorrow. So I'm going to do one more thing today. It's the same as this, except now I'm going to shade 2 lines. That's it. Okay? Now, I should have gone back to this, and I should have done this. So I'm going to get that out of here, and y is greater than -3. There's your graph. Again, use Desmos, please, to check the solution, Maddox. Use Desmos to check the solution.
Why can't you just do it before?
Because we're trying to learn to.
Because you have to learn how to draw. What's going to happen is you're going to end up having to draw out multiple lines. And you need to see how they I'll show you right now. This next part. Go to page 154. All right. Now, graph all the inequalities in a system of linear inequalities on the same coordinate plane. The area in which the solution regions overlap represents the solution set to the system. For example, all right. We are going to graph 2 lines now, and the solution set is where the shaded regions overlap. That's all there is to it. Where the shaded regions overlap. That's the solution set. Now, I keep saying this solution set. How many of you don't understand what solution set is? Okay. It's the coordinates that when put into the inequality, make it true. That's what the solution set is. All right? So I was trying to demonstrate that right here by putting multiple points in. So this is the solution set. Any of the coordinates in this region, if I put them into there, makes the statement true. That's what solution set is. It's all of the coordinates in the shaded area so that when you put them in for X and Y, it makes it true. Good? Anybody still not understand solution set? The solution set, what you did last year in grade 10, your solution set was always on the line. Now it's an area on the graph. Okay? So I have two equations. Equation number 1. X plus y is less than or equal to 5. Equation number 2. X plus 3y is greater than 0. All right, let's start by graphing that guy first. How do I graph? What's the first step in graphing here? Change to an equal sign. So I change that to x plus y equals 5. Write that down. So I'm there. Over here, is there. Okay? All right. I'm going to use my intercepts for this one to graph it. Rather than putting it into y equals mx plus b, I'm going to graph it using my intercepts. So I got to find out where my intercepts are. Again, what is an intercept? Where it crosses that axis, x-axis or y-axis. How do I find it? Well, I put 0 in for one of them and solve for the other. If I put 0 in for x, what does y equal? If I put 0 in for y, what does x equal? 5. So I'm going to graph those two right now. There and there. Is the line solid or is it dashed?
Solid.
Solid. How come, Cash?
The line.
Because I have an equals to here. So I draw this. Okay. All right. How do I?
Excuse me, Kevin, call into the office, Kevin.
How do I find out what the solution set is? Where I shade.
Plug in 0 and 0.
You hear that?
0.
I'm going to put in 0 and 0. I don't have to use 0 and 0, but I'm going to plug it in anyways. All right. If I put 0 and 0 in, that's this coordinate right here. 0 plus 0 is what?
0.
Is 0 less than or equal to 5? Is 0 less than 5?
Yes.
So do I shade up here then?
Yeah. Yes.
What?
Wait. No. No, I get it. No, I messed up.
Okay.
I got it.
Here's 0 and 0. We know that it makes that true. Does that mean it's part of the solution set? Yes. So I shade this area now. Okay. You follow that? Yes? You got me?
Yeah.
All right.
Get in there.
Getting there? Okay. So this guy, I can't use my intercepts for him because the intercepts are going to be 0 for both of them, 0 and 0. So I need to change that into y equals mx plus b. So I'll change that to blue. 3y equals negative x, y equals negative 1/3 x. All right, so I'm going to get y by itself. To get y by itself, I subtracted x and put it on the right side. That's how I got negative x. Then I needed to divide by 3 to get rid of the 3 from in front of the y. Okay. Right now, that is in y equals mx plus b form. What is your b value?
0.
Do we agree with Blake?
Yeah.
Is the b value 0 in that equation? Who doesn't know? Put your hand up if you don't know. Somebody's lying. It's plus 0. It is 0. So where do I put my y-intercept then? At
0, 0.
0, 0. So I'm right here. Where does my slope tell me to go now?
Down 1, down 3.
Down 1 and right 3 to here. Okay. Is it a solid line or a dashed line? Look at the blue, the equation at the very top. Is that greater than and equal to, or is it just greater than? Just greater than. So, oops, sorry, it's just a dashed line. So I'm going to go like this. Like that. Okay. Now, again, focus only on the blue now. I have two halves of the blue. I either got a shade above the line or below the line. Got me?
Can you use 0, 0 for that?
No, I can't. How come I can't?
It's on there.
Because it's on the line. And we know that none of the solutions are on the line because it's dashed. So I need to pick a different coordinate. Either above that line or below it. What coordinate is above that line that you want to use?
0, 1.
0, 1. Excellent choice. I would have chose that too. That's right here. So what am I trying to find out? Whether or not I shade over 0 and 1. So I put it into this equation here. 0 plus 3 times 1 is greater than 0. What is 3 times 1? 3. Is 3 greater than 0?
Yep.
Yes. All right. Here's the trick now. I'm only going to shade. So I got to shade over this guy. But I'm only going to shade in the region that is also shaded by red. I'm not going to go any higher than that. So my solution for this question is right in here. I only shade above that line where the red is also shaded. I don't go above this because none of the coordinates up here satisfy the red line. They only satisfy the blue line. And none of the coordinates down here satisfy the blue line. They only satisfy the red line. So what you're looking for when you graph two lines is the region that's shaded for both. What was equation number 1?
X plus y is equal or greater than 5. Oh wait, no, other way. Less than. Yeah.
Okay. So I have this right here. I'll give you large. Okay. So that's my red. That's my red line. Now I'm going to put in the blue line. X add 3y is greater than 0? Yeah?
Yeah.
0. Okay. So there's both completely shaded. The answer to the question, the solution set, is this region right here. It's shaded by both green and blue, which creates a purple. All right. The one other thing that you must and will get into is the boundary points. That's that guy right there, where they cross each other. Okay, that'll be important later on. So what you need to do today and tomorrow, and possibly Friday, is 6.1 and 6.2 is just get used to graphing these by pencil and using Desmos to graph it. Okay? All right, that's it. You can go to work now.
What is this?